Hey guys, in this video the brilliant Miss Digby is going to be working through lots of questions on inequalities. 15 different questions, and if you look at the pinned comment that will take you to the different time points for each section. If you want more practice questions, if you really want to show you that you've understood this, then you can go look at the thousands of practice questions over my website.
The easy questions, we're going to write inequalities which identify all the numbers which are indicated on the diagram. So we look at the first diagram. We have an arrow that's pointing to the right, and there is a circle that is hovering above 0. So what this is showing is all the numbers are allowed. All the numbers that are allowed are on this arrow. So for example, 1, 2, 3, any of these numbers that are along the arrow, even 5, and then anything past that, because the arrow points off to the right, so any number to the right is allowed. We could have 6, we could have 7, we could even have 100, we could have numbers larger than that still. We can also have numbers in between, so we could have 0.5, we could have 1.5, we could have 2.5, and then even smaller breakdowns like 2.6 or 2.7. So there's really an infinite number of integers, infinite number of decimals in between that are allowed on this line. What we're not allowed are numbers to the left of this line. So for example, we're not allowed -1, we're not allowed -2. They have to be on the line or in the direction the line is pointing. But we don't want to write down all these numbers. What we want is a nice simple way to represent this. So here's what we write. We're going to write x referring to our number, our mystery number. You could write something else, you could write n. X is usually what you're going to see. And then because the arrow is to the right, we are going to have an inequality sign that points to the right, and that is the greater than symbol, and the arrow's pointing towards the larger numbers, so greater than makes sense. And then because the start of the arrow is here, which is above 0, then we are going to write 0, saying that x is greater than 0. X is any number which is larger than 0. So we can represent all those numbers with a very short phrase. So moving on to question 2, we're going to do the same thing. So we're going to represent x is the number that we are looking at, our mystery number. The inequality symbol, this time it's pointing to left, so I'm going to write an inequality symbol that points to the left. That's the less than sign, and the arrow is pointing towards the smaller numbers, so that makes sense. And then the circle is above the 25. So the number we're going to write is 25. And the x is less than 25. You're allowed to have any number which is less than 25. So 24, 23, 22, even down to 2, 3, 0, and even any negative number. Moving on to question 3, you can start in the same way. We always start off with x, and then looking at the inequality sign, it's pointing to the left. So I'm going to have an inequality symbol that points to the left, the less than symbol. The circle is above 4, so I'm going to write 4. Now there is one final difference here, and you'll notice that the circle in this question is coloured in black, whereas in the previous questions it was coloured in white. Now what this is all about is if are we allowed 4 or not? What if we wanted to allow 4? So if we just put an extra line on the less than symbol like this, then that turns it into the less than or equal to symbol. And that means that as well as allowing all the numbers that are less than 4, like 3, 2, 1, 0, -1, we're also allowed to use 4 itself. That's different to question 1 and 2, because in question 1 and 2 the circle is hollow, it is not coloured in. So in question 1 you are not allowed 0 itself, and in question 2 you are not allowed 25. But you're allowed anything really, really close to 25. You could have 24.9 or 29.999, but you can't get to 25 itself. Moving on to question 4, we do start the same way, but you'll notice that this time there isn't an arrow, and that means that rather than having an open-ended side that you can go to infinite negative numbers or infinite positive numbers, we're contained between 12 and 17. We're not allowed numbers smaller than 12, and we're not allowed numbers that are larger than 17. So in this situation, we're going to write 2 less than symbols, and we're going to write down the 2 numbers. So we have a 12 and we have a 17. So we're saying that 12 is less than x, and that's true. All the x values will be larger than 12. And we're also saying that x is less than 17. All the X values have to be lower than 17, 16, 15, 14, but they can't be greater than 17. So let's try that again with question 5. So we're going to write down our X. We're going to recognise that there are no arrows, so we use less than symbols. And we're going to have numbers on both sides. So we're going to have the 22 and we're going to have the 26. Now again, notice for this one, we have a hollow circle and we have a solid circle. And the circle is solid. That means you have to put an equal symbol on your inequality. So 22 is less than or equal to 22. So we're allowed to have the actual number 22. Whereas with 26, that's not coloured in, so we are not allowed to have 26 itself. Moving on to the medium questions, we're going to work backwards now and we're drawing the diagram ourselves. Now it's given us an inequality. So for question 1, X is greater than or equal to 25. So we're going to draw a circle at 25. Next thing we need to do is think about the direction of the arrow. So look at the inequality symbol. This inequality symbol is pointing to the right, so the arrow is going to point to the right. There's no rule about how long this arrow needs to be. As long as you have any kind of length of arrow that's clear and it's pointing in the correct direction, then that's going to be absolutely fine. The final thing to notice then is if the circle is to be coloured in or not. Now, X is greater than or equal to 25, does have an equal sign, so we are going to colour this in. And one last little note here, you might think, well, that's written a little bit differently than it was in the easy questions. That's just how you type it on a computer keyboard. So if you just want to quickly type greater than or equal to, you type a greater than sign, you type an equals after. It's a little bit faster for me to set up the questions that way. Question 2, we're going to follow the same process. Firstly, we're going to identify the number we are working with, which is a -4. We're going to draw a circle at -4. Then we're going to look at the direction of the arrow. Now this is the less than symbol, so that's pointing to the left. So the arrow has to point in exactly the same direction to the left. Then we just think to ourselves, right, is there an equal sign here? I'm colouring the circle, and there's no equal sign, so we are not colouring in the circle. Question 3, again the same method. Identify the numbers first. Now we have 2 here, we have 50, and we have 75. So if you have 2 numbers, then draw 2 circles. A circle at 50 and a circle at 75, which we're just going to pop in between 70 and 80. Now with the arrow, no matter what here, these are just going to be drawn together, joined up. There isn't going to be an arrow, there's no open-ended side here. The final thing to do is decide, are we colouring in the circles? Now the 50 has an equal sign on it, so we have to colour in the 50. But the 75 doesn't have an equal sign, so we are not colouring in the 75. So that's our final answer. Question 4, again repeat the process. Now we have a 22, so we can draw a circle at 22, nice and easy. But then we have a 50 divided by 2. Now 50 divided by 2 is 25. So we want to draw our circle at 25. So if you have a fraction or have some kind of calculation there, just solve the calculation and use that instead. Now, given that we have 2 circles, these are going to be joined together, no arrows. And then are we going to colour in the circles? Well, neither number has an equal sign, so we have our final answer already. Now for question 5, we have 25 over 2. 25 divided by 2 is 12.5. So we'll do a circle at 12.5 in between the 12 and 13. And then we have 18. So we'll draw a circle at 18. Again, if you do have 2 circles, join them up. And then are we going to colour the circles in? Well, actually, both numbers do have equal signs, so we're going to colour in both circles. To have 12.5, we're allowed to have exactly 18, and we're allowed all the numbers in between those, including decimals. Moving on to the hard questions. The first question says, what is the maximum possible integer within the region? So we want the largest possible whole number that is in that region. Now this is going to be the -3 because we're looking at the largest circle. The other one is a -10, that's smaller. This one's a -3, that's the largest one. And so our range of values can't go any higher than -3. We can't go any lower than -10 or any higher than -3. Our number x is contained within this region. So we're looking at -3. Now we have to decide, are we actually allowed -3? Now it's a filled in circle, so we are allowed -3, and -3 would be the answer. X will be -3, that's the maximum possible integer. Now if that circle wasn't coloured in, and it would be an empty circle, then the maximum possible integer will be -4, because if the circle isn't filled in, then you're not actually allowed that number. So we'd have to go to the whole number underneath. We couldn't have a decimal because it specifies integer. Now, moving on to question 2, things are getting much more difficult now, and we have to draw the region x², take away 8x plus 12 is greater than -3. It's quite a mouthful. We've got a quadratic there, so we're starting to mix in other topics. So the first thing we want to do is solve the quadratic. Now I'll do a quick recap here, but go and watch the video on solving quadratic. So we have x² take away 8x, and then I want this to be equal to 0, and the question is -3. So first let's deal with a number. Well, to get rid of -3, I want to add 3. I'll have to add 3 to both sides, and so that'll give me a +15 here rather than a 12 because I've added 3 on. Then with the greater than symbol, I'm going to pretend that it's an equals sign for now. We'll factorize and solve, then at the end we'll talk about how to put that greater than sign back in. So let's factorize. Now this is x², so it'll always be an x and an x because x times x is x². And now I want to fill in the 2 other numbers that I'll need. Now, little trick with these is we want 2 numbers which multiply to make +15 and add to make -8. So +15, I could do 1 times 15, or I could do 3 times 5. Which one of those is going to make it 8? Well, I think that 5 is going to make 15, and the 3 and the 5 will make the 8 somehow. Now it's a -8, so a -3 and a -5 should make -8 if I add them together. Finally, to solve, what I'm going to say is x equals +3, because if the first bracket was a +3, the first bracket would be 3 take away 3, which is 0. And then no matter what the second bracket is, if I'm multiplying that by 0, I'm going to get 0. The same thing happens with the second bracket. That will be equal to a +5, because if x was 5, then the second bracket would be 5 take away 5 is 0. Then we're multiplying everything else by 0, and the answer is going to be 0. And given that my answer is a 3 and a 5, I'm going to have a circle at 3 and a circle at the number line. Now what we need to do is consider that greater than symbol, and we've got to work out how this number line is going to look. We're going to have arrows pointing away either side. Like you can see, question 5 looks like that. Or are the 2 circles going to be joined up? Like you can see, question 4 has got the 2 circles joined up. Which option are we going to take? So the way we're going to do this, we're going to choose a number to test. And I'm going to test 4 because it's right in the middle. I'm going to see if 4 will satisfy the inequality. And if it does, then the 2 circles will be joined up. And if 4 doesn't, then we'll have the arrows pointing in either direction. Now, what do I mean by 4 satisfying the inequality? Well, I'm going to swap x with 4. So rather than x², we're going to have 4². Rather than having take away 8x, it'll be take away 8/4. Then we add on the 12. Now, if all of that is greater than negative for satisfying the inequality, so let's work through it. So 4² is 16. 8 times 4 is 32. So 16 take away 32 is -16. -16 plus 12 is -4. So we're saying that -4 is greater than -3. And that's not true at all. -4 is less than -3. So 4 is not allowed. That means that the arrows are going to have to be in such a way that we do not cover the 4. That means that they're going to come downwards from the 3 and upwards from the 5. And just the arrows and the circles written in blue, that pair is the answer. The rest is working out. One final thing to consider is if the circles are coloured in or not. Now, the inequality doesn't have any equal signs in it, so we're not going to be colouring in the inequality. So that is our final answer. Now, question 3 works the same way, it's just a slightly more complicated inequality. So we have 2x squared take away 11x, and then again we want it to equal 0, and we have a -6 where the 0 should be in the question. So we have to add on 6. So 9 plus 6 is going to give me a +15. So let's factorize, and word, then you must have a 2x and a 1x to multiply together to make 2x squared. Then look at our little trick. So we want two numbers which multiply together to make 15 and add together to make -11. So the options are 1 times 15 is 15, or 3 times 5 is 15. Now, none of those alternatives could possibly add together to make -11. From the previous question, we know that 3 and 5, the largest they can make is 8, and then 1 and 15 could make 14 or 16 if we take away. That's not going to work. But because we have a 2x, we're allowed to multiply one of the numbers by 2. Now, it's 1 and 15, we times a 1 by 2. 15 and 2 would give us 13 at the smallest. So it must be 3 and 5. And how can we get an 11 from 3 and 5? Well, we'd have to multiply the 3 by 2. The 3 has to go in the opposite bracket to the 2, so they get multiplied. And the 5 would go there. So 3 times 5 is positive 15. And then when you multiply all this out, x times 5 is 5, 2x times 3 is 6x, so 6x and 5x is 11x. But it's -11x, so we are going to need a -5 and a -3. Then we are going to solve, and again it works similar to the previous question, so x is going to be a 3, because that will make the second bracket, you multiply by 0, you get 0. But then for the first bracket, if we said that was 5, it would be 2x take away 5, and 2 5s take away 5 is 5. So actually, x is going to have to be 2.5 because we have to multiply the number by 2. 2 times 2.5 is 5. 5 take away 5 is 0, and then that's going to give us a 0 when we multiply. So looking at the number line, we want a circle at 3 and a circle at 2.5. So these two are quite close together. Now, again, I need to figure out where the arrows go, and I can't really test anything in between 2.5 and 3. That'd be quite complicated. I could pick 2.6 or 2.7, but that would be a bit of a headache to work out. But what if I tested something like 1, a nice simple number? I mean, I could test 4, I could test 5, get some quite large numbers there to work through. So let's test the 1. So we would have 2x squared, so 2 times 1 squared, take away 11 times 1, and then add on the 9, and that has to be greater than or equal to -6. So let's work this out. So use BIDMAS rules. We have to do an index first. So 1 squared is 1 times a 2 is 2. 2 take away 11 is -9, and plus 9 is 0. So we're saying that 0 is greater than or equal to -6. And I think that makes sense. It does. So that means that 1 is going to be allowed. So the arrow is going to have to go past 1, which means that the other arrow would be pointing the other direction, and that's going to be our answer. Now, the last thing to look at is, do I colour in the circles? Well, we do have an equal sign in the question, so we are going to colour in the circles. That means that 2.5 is allowed, and 3 is allowed as well. Now, moving on to question 4, because the number line has been done for us, so we have to work backwards now and write down what the quadratic inequality is. So, working backwards, we can see we have a -3 and a 0. So, in a factorised inequality, we know for sure that there's going to be a 3 and a 0 in there. And then if you look at the answer to the previous 2 questions, you know the sign is flipped. So, it will be a -3 or a +3, because that's the opposite of -3, and then we have the 0, and 0 doesn't have a sign, so we'll just put a plus in there. Now I'm going to multiply this out, and again, if you're not sure about this, go and watch the video on multiplying out double brackets. So x multiplied by x is x squared, and x multiplied by 0. So multiplying the first x in the first bracket has just given me x squared. Now let's multiply the 3. 3 times x is 3x, and 3 times 0 is 0. So the second part, the first bracket, has given me 3x, and I don't need to multiply the second bracket because I've already multiplied those parts already. So I have x squared plus 3x. Now again, if you look at the previous few questions, these factorised versions were equal to 0, so this is going to be equal to 0. Now for the final answer, we'll have x squared plus 3x, and we're going to need a greater than symbol or a less than symbol, so we have to change the symbol now. And again, we're going to test a number to try and see where that is. And I think I'm probably going to test -1. It's probably the easiest number to test. And I am testing something that is allowed on the number line. So I'd never be testing something like -4 or +1. So let's test -1. So we would have -1 squared plus 3 times -1. Now, -1 squared would be 1. 3 multiplied by -1 would be -3. So 1 plus -3 will be -2. So how does -2 relate to 0? Well, -2 is less than 0, but a less than symbol in my answer. And because the circles are coloured in, it's going to be a less than or equals to. And there's our answer. X squared plus 3x is less than or equal to 0. Now let's repeat the process with question 5. So I want my double brackets. It's going to be equal to 0. We have 5 and 6 on the number line, and they're both positive. So in our brackets, we want the opposites of those. We'll have -5 and -6. We're going to multiply out the brackets. So multiply the first term of the first bracket by the second bracket. So x times x is x squared, and x times -6 is -6x. Then we'll multiply the second term of the first bracket by the second bracket. So everything's being multiplied by everything. -5 times x is -5x, and -5 times -6 is +30, and that is equal to 0. So the final answer will be x squared. Now, -6 and -5 would make -11x, so we can combine those terms. And then the plus 30, and we wouldn't want an inequality symbol before the 0. So again, I'm going to test a value that's allowed on the number line to try and figure out which way around this is going to be. And I think probably the easiest one to do, again, is going to be 1. 1's normally quite easy to test. So take away 11 times 1 plus 30 has some kind of relation to 0. So 1 squared is 1. 11 times 1 is 11. So 1 take away 11 is -10. -10 plus 30 is 20. So 20 is greater than 0. So in the answer, we're going to have the greater than symbol, and then the circles are not coloured in, so we are not going to have the equal sign on there. It will be greater than or equal to. The answer is going to be x squared take away 11x plus 30 is greater than 0.
Ouch! This is why in some videos I have unexplained scratches.